Hello everyone, welcome to today's webinar. Today we will go over the first section of the first unit in Algebra 1. Algebra 1 is an advanced course in math that we offer at Penn, and it's basically going over algebra. It is a basic course in algebra, but for some of you, algebra is new. So I'm going to try my best today in this webinar to set up the rules and learn the language of algebra. Today, as I said, we're going to go over the first section of Unit 1. So next Wednesday, we will have another webinar that goes over the second section of Unit 1. So please register for that webinar. Today, we're going to go over the basic operations with monomials and polynomials. This is myself. My name is Miriam. I'm your math instructor here at Penn. I'm certified to teach math, high school math in the state of Pennsylvania, and also I've just earned my master's degree in urban education. Today in this webinar, we're going to go over the most challenging topics in the first section of this unit. What we're going to go over in this webinar is not going to be everything that you need to learn for the exam, but it's ultimately something that you may use in the future to prepare for your exam. During the webinar, we're going to have some self-check questions. So after we discuss some of the topics here, we will have some self-check questions for you to try. Those questions are not graded. Those questions are for you to assess yourself and see where you are from that topic. If everyone hears me okay and everyone is able to see my screen, if you want to type yes or everything is okay, that would be appreciated, please. Also, your questions are welcome. If you have a question regarding these topics that we're going to go over, you are able to type in your questions in the questions box. The raise your hand feature does not work in our webinars, so the only way that you're able to communicate your inquiries or questions is to type them in the questions box. All registrants of this webinar, whether you're with us today or you just registered for this webinar, will have a recorded webinar sent to them in a follow-up email. Today, we are going to go over adding and subtracting monomials, multiplying, raising monomials to powers. We are going to go over how to multiply a monomial times a polynomial and also simplifying polynomials that have mixed operations. So let's start with the first slide here in our webinar. Now, the one thing I want to bring your attention to is that algebra sometimes looks scary. When you look at the first question on that screen, you see lots of letters, powers, numbers, and operations, and that may get you overwhelmed. Now, the way to go over algebra and to understand algebra is that to realize that algebra is all about rules. Once we know the rule, no matter how scary the question looks like, we know our rule, we're just going to go ahead and apply those rules. So now we're going to learn how to add and subtract monomials. And a monomial is a term that the only operation in that term is multiplication. For example, 6x squared. The first term here is a monomial, 6 times x squared. There's no plus between the 6 and the x squared. There's no minus between the 6 and the x squared. So this term is a monomial. The same thing here for the 4. 4 is just a 4, a number. This is a monomial, 5x as a monomial. So we're going to learn how to add and subtract monomials. Now, to do that, we need to also know the rule for that. The rule says that you only allowed to add or subtract monomials that has like terms. And like terms here is that the variable part of your monomials have to look exactly the same. For example, 6x squared and 9x squared, both of these monomials are like monomials. We are able to do the operation of subtraction for the 6x squared minus 9x squared. Now, 6x squared is not a like term with a 5x. 5x has an x. It does not have an x squared. So the variable part of our monomials has to look exactly the same. And if they do, then we are able to add or subtract. Now, since we're adding or subtracting the like terms, we need to identify which like terms do we have in our question, on the first question that we have on the screen. My way of doing this, and maybe you have your own way, my way is to underline the like terms. I'm going to start with 6x squared, and also I see that minus 9 squared, these two terms are like terms. I'm going to go ahead and subtract. 6 minus 9 is what? 6 minus 9 is minus or negative 3. And I'm going to keep the common variable, the like term, the same. It has an x squared, then my answer for that part is going to be it's going to have an x squared as well. So that would cover the two monomials that have an x squared common. Now let's look at minus 15x. Do we have another term, another monomial that only has an x as the variable part? And the answer is yes. So for that one, I'm gonna have another kind of line underlining those two monomials just to tell myself that these are like terms I'm able to add or subtract. So I'm going to add and subtract the coefficients, the number that appears before the variable. Negative 15 plus 5. Negative 15 plus 5 is a negative 10, and keep the variable x. Let's go to the next monomial in order. Negative 7y. Do we have anything, any other monomial that has a y as part of its variable section? And the answer is no. So since there is no alike term for the minus or negative 7y, then it's going to go down in our answer as is, minus 7y, unchanged. Okay, now we have 20. 20 is a number. The like term to a 20 is another number with no variable. So I have a 20 and I see a negative 4. These are like monomials. So 20 minus 4 is plus or positive 16. And that's it. This is how we added or subtracted the monomials. So on the brackets on the right-hand side of the screen of your screen, I try to summarize the rules. I try to give some simple examples to demonstrate those rules. So whenever you watch the recording of this webinar, you can pause and you can write those little notes on your notebook just to keep them for your own reference, and instead of going back and forth through your study unit just to, look for one rule that you're trying to recall or use. The second question, the same thing, simplify. So simplify in algebra means do whatever you can to make this polynomial in simplest form. If you have to add or subtract or multiply or apply a power, this is how you simplify a polynomial. Since we have monomials added and subtracted, we need to look for like terms. So this process is going to repeat. We need to look for like terms. So I'm going to start with the far left monomial and try to see if we have a like monomial for that one. So negative 3y cubed. I have a negative 5y cubed. These two monomials are like monomials. I am able to perform addition and subtraction. So negative 3 minus 5 is negative 8, and keep the same variable y cubed. Next in line, 2xy. Do we have any other monomial that has x times y as their variable part? And the answer is no. Then this monomial will just go down as is, 2xy. Next, 2 or minus or negative 2x. Now 2x, it has an x as the variable part, and negative 6x has an x in their variable part. Then these two monomials are like. I am able to perform subtraction. Minus or negative 2 minus 6 will give you. So we are going to do negative 2 minus 6 will give you minus 8 and keep the x. The next one in line is y squared. Nothing common or nothing like this term. So keep it as is, plus y squared. And we don't have any numbers in our polynomial. So negative 10 is the only number we have in the polynomial. There's no like terms. Put it as is in your answer. And that's it. So again, I just wanted to repeat one of the key things that we have to keep in mind. Algebra may look scary, may look overwhelming, but really it's a simple rule. When we look at the polynomial, it's a long polynomial, but the rule is simple. Like terms, add or subtract, that's it. Again, if you have just joined us in the webinar, you're able to type in your answers in the questions in the questions box. The raise your hand feature does not work in our webinar. So now let's do a self-check question. These self-check questions, again, are not graded. These are just only for your reference, for your evaluation, self-assessment, and see if you need more help in that topic. Do you need to go back and do some readings on that topic, adding and subtracting monomials, or you're fine? So this is the question appearing on the screen. Simplify the following expression or polynomial. You have a polynomial here, and you have 4 possible answers. Now, you are able to enter your answers, but when I change my screen to that screen, will give you the option to click the answer that you think is correct. Those powers will not display as clear as now when you see it in my screen. So what I would like to do is keep that screen on. You can work on the question now, pick the answer that you think is right, and then I'm going to change my screen in 1 minute so you're able to enter your answers. So you can have your time and think about that, the same concept, adding and subtracting monomials. I'm just going to give it another 50 seconds, and then I'm going to switch my screen, and hopefully by that time you're able to pick your answer and see how things go with that question. Okay, so I'm going to go ahead and put up that question, the same question, but this time you're able to pick your answer. Is it A, B, C, or D? What do you think? I'm just going to keep it for another 30 seconds. If you haven't done your work, you still have the question up, just in a weird format here with the powers. Okay, so I'm going to close that question, and the answer for that question is C. The answer for that question is C. When you get the recording of this webinar, you can pause the video and do that question one more time and figure out why the answer is C. You can do the question and take your time and then figure out if this is the answer that you arrived at or no. If you happen not to understand why C is the answer, you can email the school and ask, this question was part of the Algebra 1 webinar. How did we arrive at C as the answer? Can you explain? And someone will get back to you through email as well. Let's look at another topic within the first section of this unit. Simplify the following polynomial or expression. 6x squared minus 3x plus 17 plus another polynomial. negative 3x squared plus 10x minus 20. Again, too much letters, too much things going around, but we need really to figure out the rules. And again, the rules are on the right-hand side of the screen. To add two polynomials, we have two setups that we can use, and it really depends on what you are comfortable doing. Do you like to do it the horizontal method or the vertical method? I'm going to go through both, and you can choose your style. Sometimes for me, myself, if the two polynomials I'm going to add they are too long, I go with the vertical. If they are not too hard for me, I just go with the horizontal. So it really depends on you, what you like to do. So to add the polynomials, we can use the horizontal method. The horizontal method is that since we have two sets of parentheses here and there, and the two polynomials are not multiplied, they are not subtracted, they are just added. So really those parentheses does not mean anything. We can just get rid of them. So let's rewrite the two polynomials with no parentheses. And this would be the horizontal method. 6x squared minus 3x plus 17 plus negative 3x squared plus 10x minus 20. Now this looks like adding and subtracting monomials. So we go back to the rule that says you can add or subtract two monomials if they are like monomials. I'm going to do the same thing. I'm going to underline the ones that I see as like monomials. So 6x squared and negative, see, there is a negative there, and negative 3x squared, both of them are like monomials, then let's add them. 6 plus negative 3 is really saying 6 minus 3. So 6 minus 3 is 3, and keep the x squared. The next one is minus 3x, or you can read it as negative 3x. So this is the second one, and I see plus 10x or positive 10x. Since they are like, let's combine them. 10 minus 3 or negative 3 plus 10, it's the same thing, will give you plus 7x. Now the 17 I see, and I see negative 20. They are numbers, they are like monomials. Then 17 minus 20 is negative or minus 3. That's it. So this really went back to our first slide. Let's do the vertical method. Let's do the vertical method. The vertical method, we're going to set up the two polynomials on top of each others and then add the like terms this way. So the first polynomial is 6x squared minus 3x plus 17, and I'm adding. The operation here is addition. I'm adding plus negative 3x squared. And remember, with the vertical method, I need to line the like monomials on top of each others. So I need to keep the order. And then plus 10x, x and x, and then minus 20. And from there, I am able to easily evaluate or add the two polynomials, and should give you the same answer. 6 plus negative 3 is 3x squared. Negative 3 plus 10, it should give you plus or positive 7x. And then 17 plus minus 20, which is really the same as saying 17 minus 20 will give you a negative 3 or minus 3. The same answer. Again, these are two methods. You're not required to stick with one. Pick whatever you like to do. Whatever, maybe it depends on the question, maybe it depends on your style. Let's go ahead and look what we're going to do if we have to subtract polynomials. Remember, negative signs and subtractions, they are a little bit more tricky than addition. We're going to see why now. So again, you can do that in two methods, horizontal or vertical method. Let's start with the horizontal. The horizontal, since we're subtracting, these parentheses, the second set of parentheses, they do mean something. We cannot just delete them like we did with the addition, and that's why subtraction is a little bit trickier than addition. The way we're going to do that is I need to write the first polynomial the same, 41y squared plus 5x squared minus 2y. Now, I have the second part of the question minus a polynomial. This minus really means minus 1 or a negative 1 times the second polynomial. So I need to get rid of those parentheses, I need to multiply negative 1 times each of the terms inside this polynomial. Negative 1 times negative 30 is positive 30y squared. Negative 1 times negative 13, it's a positive 13x squared. And then negative 1 times positive 5, that will give you a negative 5. Now again, this is adding and subtracting monomials. Look at the monomials, identify the 2 or the 3 or however number you have of like monomials. Okay, so let's start with y squared. I see a y squared here, so this term and this term are like monomials. Add 41 plus 30 will give you 71 and keep the same variable y squared. The next one in line is 5x squared. Do we have anything times x squared? Yes, we have a 5x squared and we have 13x squared. These are two like monomials. Then add 5 and 13 will give you 18. Will give you 18, positive or plus 18x squared. The next in line is negative or minus 2y. I don't see any y's there, so it's going to go down as is. I don't see any just numbers, only minus 5. Now we have the minus 5 here, and remember it was a positive, but it switched to a negative because really we have to multiply the negative 1 times the 5, the negative 1 times the negative 13. This is the most common mistake that students would do when they are asked to subtract two polynomials. So this is the answer if you choose to go with the horizontal method. The vertical method, the same idea. You just have to put the two polynomials on top of each others, keeping each column having the same kind of monomials this way. So the first polynomial is 41y squared plus 5x squared. I'm just really copying down the first polynomial. The second one, I am subtracting, so I have to be careful. I'm not adding here, I'm subtracting. And then copy down the second polynomial as is. Now the y square will go down under the y square, so we have a negative 30y squared. We also have a minus 13x squared. We have a number, plus 5. We're not going to put it down under the 2y. These are not two like terms, so it has to go by itself on another column. So what we are really saying now is that we are having 2y, negative 2y, plus or minus 0. This is a 0, nothing there for that term, and that is a 0 as well. So now we can do our subtraction. 41 minus negative 30. 41 minus negative 30 is the same as saying 41 plus 30, which is going to give you 71y squared. 5 minus negative 13 is the same as saying 5 plus 13, which is going to give you plus 18x squared. Minus 2y minus nothing, it's a minus 2y as is. 0 minus 5 will give you minus 5. The two answers are the same. Again, depends on what would you like to do. Any questions? Anything that was not clear? Okay, let's move on to a self-check. The same idea, you are, or this is another example. I will skip that and go to the self-check since I want to cover all of the material in this webinar. And if we have a little bit extra time and you still need to see how can we subtract two polynomials again, we can go back to that example. So that is a self-check, the same idea. It looks scary. It looks overwhelming that we have two long polynomials that we have to subtract. But we have to be clear in our mind that we're just going to follow the rule. No matter how the question looks, it just turned down to the rules that we have to use. So I'm going to keep that screen for about 30 seconds, and then I'm going to change my screen to the screen that you are able to choose your answers from. And I hope that everyone really tries those questions. If you're not able to try them now, you can try them later when you get the recording. And just be careful that we are subtracting. It's a -1 times the second polynomial. Okay, let me put the question on the screen so you're able to choose your answers. And here you go. A few more seconds and then I'm going to go over the answer and we can go to the next topic. Okay, the final answer, the right answer for this question is B. B is the right answer. 19m squared r minus 9m squared plus 18r squared plus 12m minus 2. It's a long answer, but it is the right answer. Okay, let's move on to multiplication. How can we multiply two monomials? And again, I'm going to remind you, a monomial is a set of numbers and variables that are multiplied together. So 45y squared r to the 4th power s to the 8th power, this is a monomial. Since there is no pluses or minuses, there's no addition or subtraction, this is one term, one monomial, times another monomial. Now, with multiplying two monomials that have the variables that are raised to powers, there is a rule to do that. And again, on the right-hand side of the screen, you see the explanation of what we are going to follow to find the product of these two monomials. Of course, we're going to multiply the numbers. 45 times 2 will give you 90. And then we multiply y squared times the same base variable. Now with multiplication, you don't have to multiply the exact variable. For example, what I mean by that, you are not only required to multiply y squared times another y squared. Anything of the base y, you are able to multiply together, but you need to add the exponents. So y squared and y to the 5th, both of them of the base y, 1 to the 2nd power and 1 to the 5th power. So my answer will actually be the same base y, and then add 5 and 2 will give you 7. Same thing with the r. R to the 4th power times r. And in algebra, if you have figured out yourself by now, in algebra we do not write the 1. So r here is raised to the first power. So I'm multiplying r to the fourth times r to the first, the same base r, then add the exponents. 4 and 1 is 5. Your answer for that section is r to the fifth. The same thing with the s to the eighth and s to the 10th. The same base s, then I'm going to have a base of s and then add the exponents. 8 and 10 will give you 18, and that would be your final answer. One more time, let's do another example. Negative 6p to the fifth power x to the third power or cubed times v to the ninth power times another monomial 11x to the fourth and v to the second. What should we do? Well, first multiply the numbers. Negative 6 times 11 will give you negative 66. Look at the variables. P to the fifth times what? We need to look in the second monomial for a variable with a base p, but there is nothing. Then p to the fifth will just go down as is. X to the third, and we have x to the fourth. So we have an x as the base. Add 3 and 4 will give you 7. V to the ninth, and we have in the second monomial v to the second, so we just add 9 and 2 will give you 11. Keep the base v to the 11th, and that's your answer. Any questions? Okay, let's move on to a self-check. It's getting easier. With multiplication, it's a little bit easier. Multiply two monomials. You have negative 3x squared times y times z times another monomial, 2xy to the fifth. I'm going to keep the screen. And even if you're doing the questions and you just don't choose to pick the answers on the second screen when I'm going to switch to, at least you do the questions, which is important. With math, practice is the most important thing. I can learn all the rules about algebra, but when I come to a question to pick up the pen and do it myself, I won't be able to do it unless I practice too much. In about 30 seconds, I'm going to switch to my screen and give you the option to enter your answers. Okay, here's the question with the option to click the right answer. Another 30 seconds, and then we go to the next topic. Okay, let's go over the right answer. The right answer for this multiplication problem is A. A is the right answer. Okay, let's go to another topic, which is raising a monomial to a power. Sometimes I call it myself a grand power. The grand power, that's not a vocabulary that you're going to see in your study unit, but that is what I think of. It's a grand power. It applies to everything in that monomial, or in your unit, they call it an outer power. So how would I raise a monomial like that to the second power? The rule is easy. Multiply the grand power or the outer power times the power of each element in this monomial, including the 5, because the 5 here is to the first. So raise the 5 to the second power, and when you raise a number to the second power, you do not multiply that number times 2. You actually multiply the number times itself twice. So 5 times 5 will give you 5 squared, which is 25. As we said, the rule says if you're raising a monomial to an outer power, you multiply that power 2 times each of the powers for each of the variables. So 2 times 3 will give you 6. So now y will have a 6th power. 2 times 1, because r is raised to the first power. 2 times 1 is 2, r to the second. And then we have s raised to the 7th. Just multiply 2 times 7 will give you 14. So s to the 14th power, and that's your answer. A second example, negative 3 x squared v to the 6th power, everything raised to an outer power of 4. Multiply the outer power times the power of each of the element in your monomial. So raise the negative 3 to the 4th power. Now with negatives being raised to powers, it's a little bit tricky, and I chose to just write this side note here just to remind you of an old rule that we have learned maybe in General Math 1 or other courses. The rule says if you're raising a negative number to an even number, an even power. So negative 3 to the 4th power, this example actually applies to this part of the rule. A negative coefficient, a negative 3 raised to an even power, which is a 4. 4 is an even number. In that case, the negative will just go. Your answer for that will be a positive coefficient. So raise negative 3 to the 4th power will give you positive 81. 3 times 3 times 3 times 3. Or it's going to give you the same answer if you multiply negative 3 times itself 4 times. Negative 3 times negative 3 times negative 3 times another negative 3 will give you again 81. Now, what if you're raising a negative number to an odd power? And on the right-hand side of the screen, I chose to give you a tiny example just to demonstrate that. So in that case, we're raising that monomial with that negative coefficient to the 5th power. 5 is an odd number. Negative 2 is a negative number. In that case, your answer will be a negative answer because negative 2 times itself 5 times will keep the negative. So this is something we need to keep in mind, and it's a common mistake that students will fall into whenever they have a negative number raised to an odd exponent. So back to our example. So we're raising that monomial. We did the negative 3 already. We need to deal with the variables. So we have x to the 2nd power multiply 4 times 2 will give you 8. So it's going to be x to the 8th power. It has a 6th power. 6 times 4 is a 24, and that is the result or the simplified form of this monomial raised to the 4th power. Any questions? The raise your hand feature does not work in our webinars. If you have a question, you can type your question in the questions box. I'll be able to see your question and who asked the question as well. Okay, let's look at a self-check. And those self-checks again are not graded. These are for your self-assessment. Simplify. Negative 3g squared h I to the 5th power, everything raised to an outer power 3. What should we do? Which rule we're going to go by to simplify this expression? I'm going to leave that for 30 seconds, and then the screen will be switched to be able to enter your answers. Okay, here you go with the option to enter your answer if you choose to. Another 3 seconds, and then we can go to the next topic. Okay, thank you for everyone who have voted and given their answers. Again, those questions really is for you, and really you don't have the time to see who got that question wrong and judge them on their understanding of the topic. We are here learning together. I do mistakes too, and I learn. Even with my, experience in math, I do mistakes. So it's good to see if you have done a mistake, we learn from those mistakes. If you didn't do a mistake, it means that you are on the right path. You can go on to the next topic. Okay, let's then look at the answer. The answer is B. B is the right answer. If you look quickly on that question, since it's a really fast problem to do, -3 raised to an odd power will give you a negative answer. So those two answers are wrong. Now, -3 raised to the third power is -27. G to the second times 3 with the exponent, that will give you the 6. H to the first times 3 will give you h to the third power, and then I raised to the fifth. 5 times 3 is 15. That is your right answer. Okay, and Zara is asking how to do decimals. So do you mean if you are raising a monomial that has a decimal coefficient, how would we do that? Is that your question? Please type yes if that's your question. Okay, so if you want to explain your question more about the decimals, how to do decimals. Okay, meanwhile, let's do the multiplying a polynomial times a monomial. So in this case now, we're not multiplying two monomials as before. We have a long polynomial times a monomial. So I hope that everyone sees my screen. I'm not sure if you're able to see my screen. Okay, so let's do the first example and build up the rule on that. Now, the rule says if you are multiplying a monomial times a polynomial like the one we see, we need to multiply each term in that polynomial times the monomial outside. So I need to multiply 5w times the first term, and then 5w times the second term, and then 5w times the third term, and then 5w times the fourth term. If we do that and do the operations correctly, either subtractions or addition, simplify or combine like terms, if any, then this is how we multiply the monomial times the polynomial. Let's start then. 5 times 2 is 10. W times x to the fifth. There is nothing that says w here in that term, so w will just go down as is, and x to the fifth will be the same as is. 5 times 5 is 25. The sign here is a positive. Positive 5 times positive 5 is positive or plus 25. W times the variable parts, I have a W here, that's to the 1, and that's to the first. 1 and 1 is 2, so W to the second. I don't have anything with the x, then x to the third as is. 5 times -10 is -50. Let's do the variable part. W to the first times W to the fourth. Add the exponents, then it's going to be W to the fifth. Positive 5 times positive 30 will give you positive 150, but we still have a variable here that we need to consider, so it's going to be 150W. And that's your answer. Let's check then in that line, do we have anything that's common like terms so we're able to combine? We have a W to the fifth, no. X to the third and x to the fifth, no. So nothing here to simplify. This is your final answer. Let's do the second one a little bit trickier because we have the monomial having two variables. Okay, the same rule, multiply the monomial times each term inside that polynomial and then add or subtract or simplify if possible. Negative 3 times 4 is negative 12. X to the fifth times x squared, add the exponents, x to the seventh. Y squared times y to the seventh, add the exponents, and that will give you y to the ninth. Done with the first term. Negative 3 times 9 will give you negative 27. X to the fifth times x to the first, that will give you x to the sixth. We just added the exponents. Y to the seconds times nothing here for that, so it's going to go down the same. Negative 3 times negative 5 will give you positive 15. And then x to the fifth times nothing here corresponds to that, so x to the fifth will go as is. Y to the second, and we have y to the third, add 2 and 3, that will give you y to the fifth. The last term, negative 3 times negative 2 is positive 6. X to the fifth and x to the second, add 2 and 5 will give you x to the seventh. Y to the second times y to the seventh, add the exponents, is going to be y to the ninth. We're done with multiplication. We need to just have a final look at that line and see if we have any like monomials that we're able to combine. So I'm looking for x to the seventh, y to the ninth. That's a no, no, and yes. X to the seventh and y to the ninth, exactly the same variable part, I'm able to add or subtract. Negative 12 plus 6 is negative 6. And keep the same variable, x to the seventh, y to the ninth. All of the other monomials, they don't have any corresponding ones that are like. So negative 27 and x to the sixth, y to the second, plus 15, x to the fifth, y to the fifth will stay the same. That's it. Okay, so the rule is simple. Maybe the application of the rule is a little bit tricky because we have to multiply, consider adding the exponents, and then we have to simplify. We only look for like terms to add or subtract. So it's a lot of things that's going on when you do the process of multiplying a monomial times a polynomial. That's why practice is the only way that you're able to master those kind of questions. Those questions looks long and overwhelming with letters, powers, and numbers and negative signs and everything like that. But with practice, from the look of the question, you know how you're going to proceed in the question to get to the final answer. Okay, self-check. And I'll appreciate if you take the time to do it now. And also you have a chance when you get the recording. So I'm going to keep that for 30 seconds. And I'm going to wait also for Zara to specify the question. I think you said something about decimals and fractions, which is not of the scope of the algebra, but I'm not sure if this is something ahead in the course or that is with the fractions unit. So let me know if this is with the General Math 1, Zara, and it's the fractions or some other unit within a math course that we offer, please. Let's put the question for you to be able to choose your answer. And here you go. Okay, the answer is D, but there is a typo here, and that should say 10t u to the fifth. Everyone actually has to have a t here. a t here. So the answer is negative 3t to the third u to the third plus 10tu to the fifth plus 2tu to the second. So when you get the recording again, you can work on that question and see if you get the same answer, D. Okay, let's move on to the next topic, which is, I think, the last topic in this webinar. How do we simplify the polynomial that you have on the screen? Now, this polynomial is different than the other polynomials that we have gone through so far because of one main difference. This polynomial has two main operations. One is addition, and the second one is multiplication. Now, the question is, do we multiply first and then add, or add first and then multiply? If you remember back in elementary school or maybe the beginning of middle school, we learned the order of operations, and they taught us that PEMDAS to just remember which order, what to be done first. So the parentheses would be first, exponents second, multiplication, division, addition, subtraction. That tells us, since we have multiplication and we have addition, that tells us that we have to multiply first. We cannot add these two terms if they are like terms. So let's multiply first and then add the 10a squared b. So I'm going to keep 10a squared b as is, since we're not going to add right now, plus the product of 6ab times this polynomial. So now we are back to multiplying a monomial times a polynomial. Multiply each monomial times each term in this polynomial, the same rule. So 6 times 2 will give you 12. A and a squared multiplied together will give you a to the third. Add exponents. B times b is a b squared, given that that's a b to the first and b to the first. Okay, 6 times negative 4 is a negative 24. A times a is a squared. Add the exponents. B to the first times b to the second, b to the third. Okay, the final term, 6 times negative 5 is negative 30. A times a is a squared. B times nothing there, so b will just stay as is. We're not done because we have another operation that we have to do. This monomial plus this polynomial. Remember we said since we're adding, those parentheses doesn't really mean anything, so we can just delete them. So I'm gonna literally just erase them, and that would be our question that we need to work on. So we are back to adding monomials. So with adding monomials, let's remember the rules. It says that we are not able to add or subtract monomials unless they have like terms. They have the exact look of the variables. Let's see if we have any of these. 11a squared b, a to the third b squared, no. A squared b to the third, no. A squared times b, this and this are like monomials, then we can subtract. 11 minus 30 will give you negative 19. Keep the same variables since they're like. The other two terms are not like, then they're going to go down the same in our answer. Minus 24, a squared, b to the third. That's it. Let's do another one. DC minus 2DC times a polynomial, or a binomial to be specific. A binomial is a polynomial with two terms, so it's a binomial. Okay, so since we're going to multiply first, I'm going to keep the DC as is, minus, and then multiply. Since I have my minus outside, I'm going to multiply 2DC times each term, not negative 2DC times each term. Or If you want to do it another way, you can say, well, I'm going to add, but I'm going to keep the sign, the negative sign with the monomial inside, and I still have to multiply first. I still have to multiply first. So the negative sign, remember negative signs is a big deal in algebra. It just changes everything around. 3c squared. Now, the way I like to do it is to keep it simple and keep the sign as a negative outside and then apply the negative sign after we multiply. So the way I prefer to do it, just want to show you the two options, but I'm going to do it this way. The first way showed you. I think that's more straightforward than the second way. Both of them are correct. So I'm going to do minus and then multiply. 2dc times negative 4. So positive 2 times a negative 4 is a negative 8d squared c to the fifth. Positive 2 times positive 3 is a positive 6d to the fourth c to the third. Now, remember, a negative times a parenthesis, it means negative 1 times the parenthesis. So I'm not able to just erase the parentheses like I did in the first example. So I'm going to do dc, negative 1 times a negative 8 is a positive 8d squared dc to the fifth. Negative 1 times a positive 6 will give you negative 6d to the fourth and c to the third. And that's it. Now, let's add or subtract if possible. I don't see anything that's like terms, so this is your final answer. One last self-check, the same concept. A monomial plus a monomial times a binomial or a polynomial. So what should we do first? And you know the answer. It's going to be multiplication, and then you apply the addition. If possible, if there's like terms, you do go ahead and add. If not, then you're just going to write the y in front of the expression, and that would be your final answer. So I'm going to leave that for 30 seconds. You know it by now. And for Zara, I think you're referring to the decimals unit in General Math 1. So let me know if this is what you're referring to. Okay, great. So if you are able to email your questions, within this webinar, you will see 3 handouts. Those handouts, each one will talk about something. One of the handouts will show you how to email your instructor. It's a little bit of a lengthy process to get to that screen where you email your instructor a question, but one of the handouts will go over how to email your instructors. Some of you may have a student portal that looks different than the others. I have included all of the kinds of the portals that we offer our students. Pick the one that matches your portal and follow the steps. I try to make it as simple as possible. And you can email your questions to me, please, and I will reply back to you either by calling if I felt like the question is too hard just to write out the answer, or maybe I'm going to include my answer in a slide. Let me know what the question is and we'll see how we can talk about that. Okay, so I'm going to put up the answer, the question there, and you can enter your answers. Okay, the answer for that question is C. C. And remember, it has to be a negative y, because eventually when you multiply y times negative 2, it'll become a negative y, but you have a y there. Negative 2 plus 1 is a negative 1y, which is negative y. That's why this is the difference between this answer and that answer. The answer is C. Now in this next slide, I thought just to bring up all of the kinds of polynomials with operations, just to look at the difference, what to do in which case. The first one is adding or adding or subtracting monomials. The second one is subtracting polynomials. The next one is multiplying a monomial times a polynomial. The third one is mixed operations. Which one to do first? We learned it's going to be multiplication. Having them on the same slide, it may help us distinguish between each case and understand why we proceed on each question differently. And I provided in orange here, I provided the answers, so you're able to work on these and know the difference in each steps in each of the cases solutions, or work out what is the difference. Why did you multiply here but not here, and so on. So this is part of the learning process, just to distinguish between the different cases. And that's it for my presentation. We went over adding and subtracting monomials, multiplying monomials. We learned we have to add the exponents. Raising a monomial to a power, we multiply the grand power times each power inside the parentheses. Multiply a polynomial times a monomial. Using distribution, you distribute the monomial over each term of the polynomial, and then simplify polynomials with mixed operations. Multiplication will go first, and then comes subtraction or addition. How do you prepare for the exam? Of course, you need to prepare for the exam. Some students would just take the exam as a tester, just to see how hard the exam is. Now, it is maybe good if you have a really hard, good background of algebra, but if you didn't have the opportunity to study algebra before, or maybe you have studied that long time ago, you need really to go to the study unit, finish the reading, the assigned readings there. Watch that webinar one more time if you would like to. Watch the available recorded lectures. I'm working on adding more recorded lectures for each unit on that course. So keep watching and see if anything added. Watch that video. Work out the practice exercises. Sometimes it's called self-checks, or sometimes it's called in your portal Discover More. Those are questions relevant to the readings that you have done. So keep a notebook, write your work out and answers, and understand why you have got to the answer by using the answer key that we provide for each of those questions within the course. Use the suggested resources provided in the handout. Now, this webinar will come with 3 handouts. You're able to download them as we speak now, or if you're not with us today, you can download them from the follow-up email that will be sent with the recorded webinar. One of the handouts will go over how would you email your instructor if you have a question. And as I said, not all the students have the same platform as the others, so I've included all of the kinds of the platforms that we offer our students. Pick the one that you are on and follow the steps for how would you email your instructor if you have a question. Number 2, the second handout will teach you or show you where to or how to use the materials in your portal, where to do the readings, how to find the answer key, how to go to the life help, how would you schedule an appointment with your instructor or teacher assistants to discuss some of the questions. All of that will be in another handout. The third handout, I'm not sure if I'm going in order, but the third one will suggests some instructional videos from Khan Academy and other YouTube videos. Those ones I have selected, they are so relevant to what we go over on the first unit of this course. So if you want more practice, more videos, this handout will have the links to each of the topics that we went over today. Literally, you have just only to click the link and watch and take notes. So these are these should help you with the exam. If you want to speak to the instructor, you can call the school, and here's the number from 9 to 6 Eastern Time. If the instructor is not available at the moment in a webinar or a meeting or just gone for the day, a teacher assistant will take your question. Either they are able to help you or will just take a note for the instructor for the next day to call. As I said, you're able to schedule appointments with your teacher assistant or instructors really for any subject, not only math. And the link for math is provided in one of the handouts. Any questions? Any questions, a general question on the course, the program, or a specific question on the webinar? I'm just going to wait for a few seconds. I'm over the time by 5 minutes, so a few seconds. If you have questions, you can type them in the questions box. Okay, I thank you everyone for your attention and for your attendance, and also for everyone who registered for the webinar. You will receive a recording for the webinar. Please watch it again, do the self-checks within this webinar, and use all of the material provided for you either outside the Penn Foster portal or within your portal. Thank you so much and good luck in your exam.